Greetings, awesome physics students. The first idea we want to talk about in physics is motion diagrams. And motion diagrams are a really simple idea, but they're extremely useful and they help you understand the motion of an object. We're just going to start in one dimension. So we're going to talk about motion diagrams in one dimension. So the idea with a motion diagram is that you look at the position of an object, let's say a car. You look at the position of that car at equal time intervals. So let's say t equals 0, you look at the position of the object. Then half a second later, you look at the position of the object. And then you keep looking at it every half second. So this would be 1.5 seconds later. Okay. This is a one-dimensional situation, so we're going to use a one-dimensional coordinate, x. And for this example, we're going to put x equals 0 here. The position of the particle in this example starts at, let's say, 1.5 meters. And then it increases to 3 meters here, 4.5 meters here, and 6 meters here. Okay. So this motion diagram allows us to track the position. In this case, it goes from 1.5 to 6 meters, from 0 to 1.5 seconds. A very useful idea that we're going to talk about here is displacement, and that is the change in position. And this variable delta means change in, and that's going to be a very useful thing that we're going to see over and over again. So anytime you see this delta, that means the change in, we're tracking the change in a variable, not just the variable itself, but how is it changing? Is it increasing or is it decreasing? To do this, the way we calculate this is we take the final position and we subtract from that the initial position. And this is always this way with the delta. We always take the final minus the initial. Okay, it's a universal thing with the symbol delta. So in this particular case, let's say we track the particle going from 4.5, it ends up at 4.5, but it started at 3 meters. Okay, so we can define our final and initial points however we like. For this example, let's choose the final point to be 4.5 and the initial point to be 3. So in this case, the change in position will be 4.5 meters minus 3 meters, which is going to be 1.5 meters. Okay, that's a positive 1.5 meters. The displacement, and this is the displacement here. Let me just write this down. The displacement is telling us how the position changes. Positive 1.5 means the position is becoming more positive by an amount of 1.5 meters every time interval. These time intervals in this case is half a second. An important thing to note here is that the position and the displacement don't have to be both positive and negative at the same time. So for example, if we were tracking this at, if it were going from negative 100 meters to negative 90 meters, the position in these 2 points are both negative. But if it goes from negative 100 to negative 90, the displacement or the change in position is a positive 10 meters. Right? Final is 90, negative 90. Initial is negative 100. If you subtract negative 90 minus a negative 100, that's going to give you a positive 10. So the displacement may be positive or negative separately from the position itself. Okay. Finally, let me just note we use the symbol delta t with to denote the difference in the time interval, or the difference in 2 times, and it's computed the exact same way. We just take the final minus the initial. And this final and initial point correspond with this final and initial point. Okay, they have to correspond to the same points. Okay, once we master this in one dimension, then we're going to take this up into higher dimensions, 2 and 3 dimensions. All right.